Hello, everyone, and welcome to our first webinar on the value of generative design for education. I'm Dea from the 3D Experience EDU marketing team, and I will be your host today. Today, with the help of our experts, we will explore how you can transform your classroom with generative design. This revolutionary tool is driving innovation, efficiency, and sustainability across various industries, making it a must-have in modern engineering. But why is generative design so transformative? It empowers engineers to create lightweight and high-strength components, which are in high demand in various fields like aerospace, automotive, and even medical devices. It also fosters a culture of efficiency, reducing material waste and cutting time to market. As generative design considers all manufacturing constraints, mastering these skills ensures that engineers stay at the cutting edge of technology, pushing the boundaries of traditional engineering. Educators, if your main goal is to prepare engineering students for their future careers, boost their career readiness by equipping them with emerging skills in generative design, then this webinar is for you. Let's see today how we can help you align the skills with the ever-evolving needs of the industry. And talking about industry, this will be our next topic, understand the power of generative design with our CATIA expert, Sébastien Cetre. Then we will see how you can transform your classroom with our education experience, our offer for educators with our EDU expert, Yves Jeunesse. And then we will try to give you more offer details and see how you can empower the workforce of the future with our EDU sales, Romain Fauché. And last but not least, we will have a 10-minute Q&A session, so feel free to ask all your questions during the webinar. So, Sébastien Cetre, the floor is yours.
Hello, thank you, Dea. So, right now I'll present what is generative design and how it is used in the industry. So, first, it's very important to understand what are the current challenges that the different companies of all industries are facing. So, first, we are also companies, for example, established big OEMs, are facing new competitors, new flexible companies that are developing new products. For example, if you look at the EV markets, there's a lot of startups getting there, which are more flexible and are ready to change their design processes. And to compete with that, they need to adapt. They need to change the way they are working. So designing faster, but also designing better, meaning the expectation from customers and also regulation are always more important. So we need to answer that. And lastly, there never been that much turnover between the companies. When you take new engineers, maybe they work 2 years at a company, then they go to another one, and so on. This wasn't the case some years ago. So with so many people switching between companies, the onboarding is really key for the enterprise to really transmit the knowledge. So let's see how do we design a part. If you need to design a product, for example, if you take the standard way of doing it, like we did 20 years ago, and a lot of people are still doing it like this right now. If you use, for example, disconnected CAD and CA softwares, it always starts with the engineering specification. So the designer will look at the specification and will try to guess the right shape, the right geometry that fulfills the specification. Then after finding the shape, he will send the model to a simulation team. We'll do, for example, finite element analysis to check whether the stresses or the stiffness is respected. And there will be multiple iterations. And each iteration is quite difficult because each time the simulation expert will need to redefine the setup. So we do that for the concept phase, but also at the detailed design phase, at the end when we try to get the product ready for manufacturing. So that's the way people are used to work. The next level is if you use 3D experience, you have integration between CAD and CAE, which means it's very easy to go from the design to the simulation. Between the simulation setup is created directly on the CAD geometry. So whenever the designer will do a modification on the CAD geometry, the simulation experts can take the model and just run against the simulation. It will be automatically updated to consider the design change. So it is already a big gain in terms of time in the design process. However, the most challenging point when you do that is for the mechanical designers to send to the simulation team, and the simulation expert maybe will not be able to answer right now. Maybe you will work on that 1 or 2 days later. So there's a big delay between those two phases. And that's the next phase, is trying to push simulation for designers. So we are never asking designers to be simulation experts. That's not their jobs. But the different companies are asking their designers to start getting some fundamentals on what is a simulation, how does it work, and be able to set up a simplified simulation on their geometry. So with the help, of course, of a simulation expert, and then they'll be able to do the iteration by themselves. So these are a big game changers in reducing the times to design a product. But so far, we still have one big challenge, is interpreting the engineering specification. And for that, the designer is relying a lot on his own experience, or maybe established company best practices. So this interpretation of the specification is the main issue. And we see just how can we try to simplify that? How can we help the designer go directly on the right direction? Because maybe if you don't make the right assumption at the start, you will go on the wrong direction and waste a lot of time. And that's the next step. This is what we call generative design, is we are still doing simulation or promoting simulation for designers, but instead of having to guess the right shape, here we use, and you will see it after, we'll define and we start from the specification, which means the designer will define the specification that the product needs to respect. The software will propose a shape, an optimal shape based on the specification. And after this optimal shape, you'll be able to generate automatically a CAD geometry, validate it. And as this process is very fast, like in one iteration, you can get a product that works, you can even try to explore more possibilities. What if I change maybe the manufacturing process? What if I change the material? And so you will generate multiple alternatives and do a trade study between all of that. So that's for the concept phase. And even after, in the detailed design phase, rather than having to, again, send the geometry to the simulation experts, look at the results and do some modification, here you have tools that will help refining the geometry. So just looking maybe at a simulation result, you will see, okay, here, for example, you have a stress concentration. Let's automatically modify the thickness of these branches. So we are really helping, providing guidance to the designer all along the processes. So generative design, at first, maybe most of you know that it can be used for additive manufacturing. It's true, but actually our customers are mainly using it for standard processes like plastic injection, stamping, casting, forging, and also milling. And the main reason is that most of the parts in the industries are manufactured with those processes, not with additive manufacturing. It's a nice technology, but it's a very niche market. So being able to generative design for traditional component is really key for our customers and it's key for us. So that's why we spend a lot of resources into considering those manufacturing processes constraints right in the specifications. And so what we can generate at the end is really a product, and you see after an examples, that respect all the specification of those processes. Maybe generating ribs for plastic injection, generating beads and cutout for stamping, respecting the parting line, the thicknesses for casting, and so on. If I take these examples, it's an air intake duct, so where we have some flow going through the parts. And let's say I want to redesign this part because the performance so far are not good, meaning the performance of the flow going through the part. So what we can do with generative design is, because you can do that on multiple physics, you can do it on structure, but also flow, is first to optimize the flow, so the area for the fluid inside. So using the flow generative design approach, you can find the best shape that will minimize the pressure drop. So this will lead to a very important increase of performance of the flow system. And after, okay, you have a new shape, but at one point you want this shape to be maybe here injected. So you want also to reduce the amount of material to reduce the cost. So what you will do is use our generative design approach to optimize the structure of the parts. And as it's injected component, the structures you want is to find the best rip pattern on the shape. And using generative design, you just specify, okay, this part will be plastic injected, and the software will show you, okay, this is the best rip patterns that you can have on the part. And from the geometry, we create the detailed design, and the part is ready for manufacture. So generative design is really a new technology. It came out, I'll say, in the industry in 3-4 years ago, mainly. It's already used by more than 100 different customers that I'm working with. So it's not just something on the future, it's already there. People are using it. And as all the different industries are transforming their design processes, they need also to have people or new engineers that are ready for that. They don't want engineers that are expert in design or expert in simulation. They want people who know a bit of everything and can use and exploit resource new way of designing parts. So really, generative design is key for all industries. That's very important. And they are looking for new engineers with those skills because the people there for various years, they are still working in siloed and they want to break that.
Hello, so we are talking about, we say, transform your classroom with our education experiences. First of all, we want to discuss a little bit about what is an academic challenge you could face. So here is a selection of challenges that academic are facing. So first, it's to prepare students for their best abilities. The second one is to develop comprehensive curricula with academic timing constraint. Access to industrial data set and content to develop engineering courses is still to be very tricky. Limitation of how to do it physically and for constraint of cost of places or whatever. And so we to move to build a virtual London activities and certainly many more that we are not discussed to now. So what is our answer about that? We have developed a comprehensive curricula within academic constraints that we call education experiences. Is the challenge faced by educator with this education experience, education experience. The idea is to provide an end-to-end teaching scenario ready to be reused by educator, and an experiences-based learning which benefit from industrial scenario customized for an education purpose to meet learning outcomes, and also to provide to fit with academic curricula constraints. Those experiences are designed very modular. We have multiple education experiences like Virtual Factory and BSc, but today we will show you a teaching future of engineering, and which included, we say, a generative design module. In this education experience is target for educators that are teaching CATIA V5 and are moving to 3D experience platform. This e-learning path or learning path, we call that, it's a step-by-step and end-to-end experience around our ECAR. We will see that the advantages of the platform, digital continuity between key domains as design, simulation, and manufacturing with the same environments, and show a virtual twin like a use case. We are within 16 hours of courses. This learning path is composed of 7 modules, which we can perform independently. So the first module, it's to help to the educator to jump into the 3D experience platform in less than 1 hour. You have a good knowledge of CATIA V5, and we help the teacher to get back in the confidence level in a 3D experience platform to be able to do CAD and other topics that he have already knowledge on CATIA V5. The second module is you are doing kinematic design and analysis in the context of the ECAR. At the end, you should be able to study to design the volume area of one wishbone of the ECAR, and that is important for the next module. Next module is a generative design module. With the volume coming from kinematic design study, you can perform generative design on a wishbone and taking care about structural performance of this wishbone, and also taking care on NC manufacturing constraint at the end of this module. And the output of this module, you have a wishbone ready to perform NC machining, and you can, as we understand, the next subject is NC machining module, learning module. Next module is about performing structure simulation, and the other is about project management and teaching with the platform. So all the learning paths for sure, and for sure you will want to deep dive on specific domain. No worry about that. We have a bank of advanced learning on our Edu Space e-learning platform already accessible. And now let's take a look with on a generative design module of this education experience. So we have a small video which introduces you what you are able to do in on this learning module. So we are in the context of ECAR model. So we are working on a wishbone, and we have a volume of wishbone, and we are starting to pre-set up your environments for simulation. So we do a connection, we do so that we delimited the volume that it's a restricted area. We are doing coupling connection for simulation. And also after that, we will apply force and loading case. So we have two loading case on this module. So one is for lateral shock and one is frontal shock, just for education perspective. So we place a force. We are able to place boundary connection. So one for chassis connection and the second one is for shock absorber, and so on. After that, we will switch to, we are creating two loading case, so one for each loading case, one with front and lateral shock. After all, you are performing the first pre-simulation just to check everything is okay in terms of simulation context. After all, you are in a position to perform topological optimization. On this case, we are applying a symmetry constraint to be able to use this wishbone on left and right side of the vehicle. So we want to have a symmetrical part. On this case, we force the system to design something symmetric. We are performing the first topological optimization, and after all, we will have we have the first shape already optimized with this constraint. So we place also a weight constraint on this simulation, and after all computation, you will have the possibility to see the final shape. So here you have, I say, a preliminary result of your shape during computation. And after all, you are able to see the optimization shape. You create your first shape, and after all, when you have your first shape, you have to validate with a structural analysis your first step. And that it's your first iteration. And as always with generative design, and the best way is do not attempt that we will get the final result on the first iteration. You should have, I will say, multiple iteration to get your final result. So on the second, on lesson 6, you are doing the new iteration with optimize, and on this case, you optimize the volumes to be able to mesh a smaller, I will say, node, and to get, I will say, more detailed results. And we also possibility to do another iteration with, I will say, smaller target of weight. And after all, on this, you go on the next lesson, so lesson 7. On the third iteration, we are working to apply, I will say, NC manufacturing constraint. So on this case, you will build a new constraint. You have, I will say, after generating the topological optimization with, I will say, NC manufacturing constraint, you are able to prepare and reshape with our mining reconstruction to get, I will say, an ideal parts ready to manufacture. So at the end, you do at least the final validation on structural simulation, and you see on context the last release of your parts in context of ECAR. This content is not already available on EduSpace. It will be available beginning of July, but you certainly want to start now learning generative design. So how to do it? So you have two industrial learning as practice CATIA functionality with generative design. You are working on swim or on motorcycle. You have the same type of step: simulation, topology optimization, shape reconstruction, final validation, but also you are working on a part optimized for mining. And we have also one interesting step is to work on that we can do on generative work on two assemble parts in the same step of optimization. And the second one is to explore the driven generative design for the most, it's not basic, but it's something most simplest. That's the first one. So next, it's stay tuned with your community. So we are dedicated and private community, so only for teachers on 3D Experience Edu Academic. So you are able to find answer to your question or learn from each other. Peer and expert are here to help you. We have a great structure with wiki, a lot of knowledge posts and tips and tricks, project sharing and so on. So please do not wait to go to this community. And also we have also CATIA communities, user communities. So with our design engineering brand CATIA, meet your expert, and you will get a lot of information around our CATIA products. So do not hesitate to interact with our CATIA teams and Edu team on our community. And if you want to get more information, do not hesitate to go to our Edu website, and you will see more detail about teaching future of engineering of CATIA, but also other education experience are also in the website and all our product and portfolio. And I leave the floor to Romain to explain more detail about that.
Thank you, Yves and Sébastien, for your great presentation. Now it's time to have a look about the package and what you need to use in order to run those education experience and for the generative design too. It's quite simple. For sure, as now it is I would say the beginning and the basic of the design when you want to launch performance part directly by using the right methodology in order to find the best way for the best performance, best part, and so on. We added all the features on many packages, and basically on the package where you find a CAD system. This means this is on the 3D experience engineer role. Could be also, if you are using SOLIDWORKS, this is one role that you can use if you want to connect your SOLIDWORKS to the 3D experience platform, but also for a CATIA 3D experience or a CATIA V5. But also on the engineering expert role, and for sure also on the simulation engineer role, you will get all the features, all the widgets in order to perform generative design by using our best-in-class tools. What is included? It's quite simple. You will get a full cloud software environment. This is really important in order to facilitate the administration and the upgrade of the tools. It is fully automatic. We are performing all those parts for you, including also on all the 3D experience package, all the education experiences. For today, it is one part, one module about the generative design, but 3 weeks ago, we already did webinars about the virtual factory and how to program a robot and to put the robot in place on the shop floor. The replay is available on our website. As you understood during the Eve presentation, the education experience is the best way in order to introduce a concept. But if you want to go deeper technically on our solution, you also get all the access on the online learning experience if you want to expand your skill on one particular domain. This information, this learning are available on the EduSpace website. I will share with you on the chat all the link later. And as Yves did the presentation a couple of seconds ago, all the official communities to support you and your student in order to get the best collaboration between your partner, Dassault system, and all the 3D experience user. This is the best way if you want to have a quick chat with us about features or question about how to use the education experience, how to use the software. Many possibilities, but the value is not only there. We also deliver value at different level. For sure, the first level, it is on your school, your university. By using our solution, you will get a professional grade solution, and be sure that it will be ensure the best employability for your student. A lot of big companies are now using the 3D experience platform on cloud. This is the case of Renault. This is the case of many big companies like GLR and some others are now deploying massively our 3D experience solution on cloud and providing learning about what the big companies is now using. For sure, for your student, there is absolutely no more value. That is on the cloud. For sure, you will get a fully secure and up-to-date, as I said, solution at any time. This is really important. You understood now. 3 weeks ago, we did a webinar about the production and manufacturing. Now it is on the design and simulation. The platform is a multidisciplinary and collaborative solution for all, and this is really important. And at the end, you can provide to your student a professional certification in order to be recognized about their skills when they will be hired by a company. For you, mainly because you answered to a survey at the beginning of this webinar. For you teachers, as you understood, we deliver all the assets in order to perform your classroom, to reuse it if you want to adapt what we provide to you. Everything is available. And also, it is easy to use and ready to use cloud environment, not necessary to deploy complex IT infrastructure in order to run the 3D experience platform. Just a login and the passwords is enough in order to deliver your trainings and lessons. And for sure, we are there with our partner. You will get access to a dedicated support team in order to answer not only on the software defect. We are there also to support you, but not only if you want to share with us your feedback and comments about the education experience and all the assets that we provide. We are also there to support you. And for your student, because at the end, you are producing a student, and it is really important. They will be trained on a professional solution, and the best is class one. They can reuse your license provided by your schools and university at home in order to continue to work and to develop their own project. This is also available, and all the collaborative and secure environment. And they also have the possibilities to pass some certification to ensure the best employability. We have, I don't know how many certification available on EduSpace for them. This is exactly the same certification that the professional audience are using. And in order to have a best CV, a a certification is a really good solution in order to be chosen over another people.
All right, so I think we have reached the end of the webinar. Don't worry if you have other questions and we didn't have time to answer to all of them. You can contact our experts. So you have their their email on the screen right now. And thank you for joining. And one information before leaving, after the webinar, you will receive a quick survey, and please take 5 minutes from your time to help us improve the content for future webinars. And if you're interested in what you have seen today, please contact your local reseller or one of our speakers below. They can help you answer your questions and help you obtain this solution for your educational purposes. Thank you all for joining and hope to see you soon on 3ds.com/edu.